Hi everyone, I'm Brock. So today let's keep reviewing an AI open source project. Today I want to make some change. Previously, I will make the recording, make this video in Chinese, but today from today I will try making the video in English. The main purpose is I want to improve my oral English. So yeah, let's start. Again, we choose AI open source project from the ranking sorted by downloads. So we will choose this one, all-mpnet-base-v2. So this is the front page. And the last month, the downloads is 19 million. Here is a report generated by cloud. Recently, I noticed a comment from an audience that this report seems generated by AI. I have thought that it's very obvious that it's generated by AI, but maybe not for some audience. So now at the very beginning, I make it pretty clear. The whole report is generated by AI. I don't manually, do any change. And here are maybe some hallucination. And actually, I have found some hallucination before. But 80%, 90% of the information is pretty helpful for me because I have literally, I know nothing about these open source projects. So I think it's helpful. So I still keep using that. Okay, let's start. Core functions of this project. First part is semantic text embedding. all-mpnet-base-v2 is a sentence transformer whose primary function is to convert text into 768 dimensional vectors representations. The 768 dimensions came from MPN's hidden layer size. The mpnet-base architecture uses 12 transformer layers, each with a hidden dimension of 768. I think that it doesn't fully align with my expectation because here, right? You should tell me how this is calculated. Let's say 768, right? You should tell me is equal to so that I can understand how this number is calculated. Obviously, it doesn't follow my instruction. It doesn't specifically tell me, how 768 is generated. Imagine you are the librarian who needs to create a digital fingerprint for each book. The traditional method use keywords tags like science fiction, adventure. This can capture deep meanings. So all-mpnet-base-v2 is like a super librarian that generates a DNA sequence of 768 numbers for each book, encoding not just the surface information, but also the book's style, emotion, themes, and other deep semantics. Second core function is semantic similarity computation. Through cosine similarity calculation, it computes the angle between two vectors with scores ranging from -1. No, how to pronounce it? It's -1 or -1. Let's see. How to pronounce -1? Okay. Yeah, it's too long, so it cannot. How to pronounce okay. So -1. So in mathematical situation, we will pronounce it as -1. In programming, we will call it as -1. Okay. So it depends on which situation. Gotcha. I guess that we can have a comment here. -1. Okay. Well, 1 means completely similar. -1 means completely opposite, and mean 0 means unrelated. In this example, the value 0.85 and 0.12 are example scores. Actual similarity would be calculated by model. Sentence 1 and sentence 2 use different words, but have similarity in meaning, hence high similarity. Okay. Okay. OCAD application scenario. So it can be used for semantic search to find similarity documents. It can be used for clustering to group similar texts. It can be used for information retrieval, for REG systems, used for duplicate detection to identify redundant content. Code technology. mpnet architecture. The full name is masked and permuted, pre-trained for language understanding. Imagine learning a foreign language. The traditional BERT method is like fill in the blank given how to pronounce this one, underscore 18. You fill in M. But this has limitations. You only see surrounding words. GPT is like a word chain game. Given M, you continue with eating, but you can only see what comes before, not after. mpnet is like a smarter learning method. It combines both games. It can see context from both directions like BERT, and understand the important words order like GPT. It's like when you learn a language by doing both fill in the blanks and sentence construction, naturally more effective. When I was in high school, when I forced myself to write a short and simple English essay every day. But the key requirement I gave to myself is utilize every words and phrases I learned in that day. I noticed that not many classmates do that, but it did help me to utilize the grammar, those phrases, or some common usage much better. Second one, contrastive learning. Suppose you want to teach a child to recognize apples. The traditional method is repeatedly showing apple pictures and saying, "This is an apple." Contrastive learning is smarter, simultaneously showing apples, oranges, and bananas, telling the child apples are similar to apples. Apples are less similar to oranges. The contrastive learning strategy used by all-mpnet-base-v2 is, given a sentence, it will create positive pairs. Different expressions of the same sentence should have similar vectors. Create negative pairs. Unrelated sentences should have different vectors. Through this push more similar closer, push different apart training, the model learns true semantic understanding. Third strategy, mean pooling. Imagine you need to summarize the essence. Well, how to pronounce?
Essence.
The book has 100 pages, each with important information. If you only take the first page, similar to CLS token method, you might miss important content later. Mean pooling is like extracting the core idea from every page, then averaging them to form the book's concentrated essence. all-mpnet-base-v2 generated a 768-dimensional vector for each input token. Then, average all token vectors, considering attention mask, ignoring padding, to get the final sentence vector. This method captures the sentence's semantics better than just using the CLS token. Well. I asked it to give reference, but it seems that it doesn't give reference. Right? I mentioned you need to provide a reference, but it doesn't. So this is also some parts that the AI doesn't follow my instruction. Technical workflow. Okay. So input text tokenization, mpnet encoder. One pass flow into token embeddings, mean pooling, L2 normalization, 768 dimension sentence vector. Another part flow into 12 transformer layers, masked language modeling and permutation language modeling. Okay. Localization is use word piece algorithm to split text into subword tokens. Vocabulary size is around 30,000. mpnet encoding is to process through 12 transformer layers, each with multi-head self-attention. So 12 attention heads in total. Mean pooling means average output of all tokens. L2 normalization means normalize vectors to unit length. For subsequent cosine similarity calculation. Some concepts. Embedding. Okay, embedding. Okay, when you explain the terms, you should also explain the English translation, right? Okay. English. Right. Okay, so second one is transformer. Third one is attention. Next one is fine tuning. IEG, retrieval, augmented generation. Okay. Yeah, in this table, you did provide some concepts, but you don't provide English translation, right? That's a flaw. Okay, some key technical concepts. Sentence transformer. It's a neural network model specifically designed to generate a sentence-level semantic bending, proposed by Neil Reimers and Arina Gaucher in 2019. Traditional BERT models are powerful but inefficient for computing similarity between sentences. If you have 1,000 sentences to compare parallels, BERT requires about, oh, that's great. So you see here it explains how to calculate how 500,000 calculation came from, right? Sentence transformer pre-generates a fixed vector for each sentence with only 1,000 calculation. Then use simple cosine similarity for comparison, improving efficiency by hundreds of times. Okay, sounds interesting. Yeah, that's great. It explains what's cosine similarity. Okay, so when you give a mathematical formula, you should explain how to pronounce it in English as well, because some, right? When you give a mathematical formula, such as this one, you should give the pronunciation, the English pronunciation. Because the reader may want to read it loud, right? Speak it out. Make sense? Okay, so AB are two vectors. In our scenario, the two 768-dimensional sentence embedding vectors, A dot B, vector dot product, which is sum of element-wise multiplication, vector magnitude, okay, theta, angle between two vectors. Okay, it's, yeah, I almost forget cosine, how to calculate cosine, but yeah, it's high school, I think, high school math knowledge. So here's some explanation. Imagine two arrows in 768 dimensions. If they point to, well, I think that one thing is that when you explain, when you give a, you should use Mermaid to draw some images, because images is easier to understand than mathematic equations. Make sense? Imagine two arrows in 768-dimensional space. If they point in the same direction, angle theta is close to 0. Makes sense? Cosine approaches to 1, which is very similar. If perpendicular angle is 19, cosine will be 0, which means unrelated. If pointing to opposite direction, angle is 180 degree, cosine will be -1, which means opposite meaning. Super clear. The third key point is transfer learning. Transfer learning is like learning music instruments. If you already play piano, learning electronic keyboard will be fast because many skills can transfer, like finger techniques, music theory. All-mpnet-base-v2 works similarity. Similarly, first learning. Okay, first learn general language knowledge on 1 billion plus scale text, which is pre-training. Then fine-tuning on specific sentences, similarity tasks. This is much more efficient than training from scratch. So the process can be divided into two parts. Pre-training, train mpnet backbone on large-scale corpora, like Wikipedia book corpus, to learn fundamental language patterns. Second part is fine-tuning, training with contrastive learning on over 1 billion sentence pairs to learn how to generate discriminative sentence embeddings. System design. Okay. The first layer is input layer, includes raw text, multiple sentences, documentations. The second layer is tokenization layer, all-piece tokenizer, vocabulary, special tokens. Third layer is encoding layer, which is mpnet. Embedding layer, 12 transformer blocks, hidden size, attention heads. Fourth layer, pooling layer, mean pooling, attention mask consideration, ignore padding tokens. Fifth layer, normalization layer, L2 normalization. What is L2? Unit vector output. Sixth layer, output layer, 768 dimension sentence embedding. Two parts, similarity computation and downstream tasks. Okay. Module design. The first part is word piece tokenizer. Word piece is a subword tokenization algorithm that handles out of vocabulary or V words by splitting words into smaller pieces. This token's ID came from BERT's standard vocabulary, while CLS is 101 and SEP is 102. Are fixed IDs for separate tokens. Okay. Second module is mpnet encoder modules. Okay. Each transformer block contains multi-head self-attention, 12 attention heads. Each head focuses on different semantic relationships. Feed-forward network, two-layer fully connected network. Intermediate dimension is 3072. That's great. It explains what's how 3072 came from. That's excellent. It's standard transformer design. Residue connections help train deep networks avoid gradient vanishing. Layer normalization, stabilize training process. Third part is pooling module. Okay. Main pooling algorithm. The key to this algorithm is averaging only real tokens, ignoring padding tokens. If a sentence has 10 real tokens and 18 padding tokens, total length 28, we only use these 10 real token vectors to calculate the average, not divided by 28. Makes sense? Okay, let's look at the pipeline workflow. So first thing is the user will send the input. Machine learning is translating. The API will tokenize the text. The tokenizer will apply word piece. And then it will give back token, attention mask, token type IDs to API. API will forward positive to the mpnet. It will process through 12 layers, then give back token embedding. And API will give apply mean pooling and send it to Pooler. Pooler will consider attention mask, then give back sentence embedding to API. API will do what's L2? L2 normalize, give to normalizer. Then normalizer will give back to normalized embedding to API. Finally, API will return the 768 dimension vectors to user. Well, but I think that actually the API, what API will give the user is not the vector, but a conclusion, right? Okay, input processing, user input raw text, tokenization. Text is broken into tokens, generating attention mask, making real tokens versus pending tokens, encoding through 12 mpnet transformer layers. Each token generates 768 dimension representations, pooling average representations of all real tokens, normalization, L2 normalization, making vector magnitude 1. What does it mean? What does magnitude, vector magnitude? I know that. We just explained this in above mathematical equation. Yeah. Another reason why I want to use English to go through this report is I find that some terms I understand how to say that in Chinese, like vector magnitude. But in English, sometimes I have no idea how to pronounce it. It will cause some difficulty when I want to communicate an academic question or technical question with others in English. Yeah. Output return final 768 dimension sentence vector. Okay. Performance analysis. It's good. I don't ask it to calculate the complexity, but it does by itself. It's good. But I just skip it at a single moment. And how to deploy it is also necessary, but since I don't have the bandwidth and resources to deploy it on my local machine, so won't check it now. Okay, some key timeline. August 2019, the sentence BERT paper is published. April 2020, mpnet published. November 2021, all-mpnet-base-v2 published. Okay, so you can see from the time when this open source project is published to now, just 4 years, right? But it's already ranking really top in all those AI open source models. So very, very, very impressive. And here's some, commercial application case like Lotion AI, Slack's semantic search, open source RAG system, co-founder. Near, okay, that's great, right? Because AI understands that this name is hard to pronounce, so it gives me, how to pronounce this name. Neil Rammers, it's research scientist at Cohere AI, PhD from Technical University of Darmstadt, research scientist at Hanjin Face. Cool. Oh yeah, so when it gives the index, now it give What does it mean? Right? The H index is 45. 45 means he has 45 papers, each cited at least 45 times. That's crazy. This is extremely rare for young researchers, typically requiring 10 to 15 years to achieve. The average in computer science area, assistant professor, the average is 10 to 15. Total citation is 15,000. And in computer science, PhD on average is 500 to 1,000. Signature paper citation, sentence BERT, is over 6,000. And for NLP top conference, the citation is only 100 to 300. Okay, publication numbers. That's crazy. So the core contribution, sentence BERT in 2019, sentence transformer library, MTAB benchmark, sentence BERT. That's impressive. That's really impressive. Open source metrics. The monthly active user is 10 million plus. Top 100, top 1% in machine learning libraries. GitHub star is 12,000 plus. Top 5% in NLP tools. Fortune 500, 50%. Significant market penetration. Monthly commits, 115 plus. Very active project. Documentation score, 9.5. Excellent. Okay, SWOT. Okay. Well, all-mpnet-base-v2 itself is open source without direct validation. Its ecosystem value is immense. Right? 20, 30 years ago, Microsoft is running against the open source, right? Because it's a threat to its main business model. But now Microsoft is, now even GitHub, the representation of open source ecosystem belongs to Microsoft. So when technology increase, everything change following it. From this perspective, the reason why in human history, in the past several thousands of years, most of the time, people's life doesn't change too much. It's not because of geometry, it's not because of language, races, or politics. I think that the top reason is technology. So imagine if 1,000 years ago, the technology increase is as fast as today. I believe that 1,000 years ago, people also felt life changed so fast. Competitive analysis. Some closed source competitors like OpenAI text embedding 3 small, Google Vertex AI, Cohere embedded v3. Okay, so for large scale applications, open source solutions have clear cost advantages. But for small scale or pursuing optimized performance, closed source API are more convenient. That makes sense, right? If we want to work on something, start from commercial API. And when our application can get enough revenue, then we can think about, build our own, deploy our own model based on the open source models. Open source competitors, all-mini-LM L6v2, E5 large. Yeah, this one we already reviewed it. I have some impression on it. Yeah, the first one. E5 large v2, BGE large in v1.5. Okay, here's a recommendation how we choose, those models. That's good. Okay, good. Insights. Technical insights. Embeddings are not just dimensioning reduction, but the art of knowledge compression, right? So compressing a sentence into 768 numbers is just like considering a book to one-page summary. The key challenge is what information is worth keeping. It's just like our mind doing every night, right? We intake so many information during daytime. When we sleep, our brain will compress the information. But I believe that not different people's brain compress the information in different way. And day by day, our brain model become very different. So semantic call, context dependency, relational encoding. The implication to me is implement intelligent character dialogue matching, broad branch recommendations, content deduplication. There's so much things can work on. Open source vs closed source trade-off. The true value of open source model is not free, but controllability and transparency. Make sense? So for startup, in MVP stage, use this model to quickly validate product market fit. In growth stage, hybrid architecture. When in mature stage, fine-tuning for filtering model based on open source, build technical mode. Business insights. The success of all-mpnet-base-v2 marks the era of AI capability democratization. What? Semantic understanding, once only accessible to Google, Facebook, now achieved by individual developers. That's crazily important, right? Similar like a computer, like a World Wide Web. It enables the information accessible to normal person. Of course, how you want to utilize that information is one thing. But if you even don't have access to that, how can you utilize it, right? That's insane. Why? Open source movement plus pre-training paradigm plus cloud computing cost reduction. When, after BERT open source in 2019, barriers continuous load reached practical threshold in 2021, while globally, especially in startups ecosystem like Bay Area, Beijing, Bangalore. Who benefits? Startups accelerate SOT capabilities without $1 million training costs. Academic academia. Oh, I think one of the hardest of English pronunciation is the emphasized tone. The first one or second one? Academia. Academia. Research focuses on algorithmic innovation rather than infrastructure. Individual developers build AI applications previously unimaginable. Okay. Investment implication. Lower competitive barriers, accelerated innovation, value shifts. Infrastructure value in RAG era. Embedding model as an invisible infrastructure of RAG system, like database to web applications. Makes sense. Just as in 2000s, every company needs a website. In the 2020s, every product needs AI. But the real value isn't which embedding model you use, but data quality, application innovation, user experience, technical philosophy. Do we really need the best model? Good enough is more aligned with business logic than pursuing perfection. all-mpnet-base-v2 success is because it suits the optimal balance of performance, cost, usability, network efficiency, effects of open source. Open source project value is equal to technical quality, multiple community size. Insights for me, embedding application in virtual novel generation, intelligent character dialogue system, broad branch recommendation engine, content consistency checker, data strategy recommendation, build a specialized training data set, user data feedback loop. Commercialization path. MVP validation strategy. Cost structure optimization. Job recommendations. Okay, Microsoft. Microsoft I already applied recently. Next one. Amazon. Also applied recently. Hunting Face. I checked it out, but I don't find something I can apply for. Cohere. Let's see. Location. Okay. And custom engineer. No, we have no custom engineer. How about solution architect? Okay, solution architect. But yeah, but it's not located in America. That's bad. Yeah. Support engineer. No. Actually, you see the location. It's actually I don't know, but right? Because when I use a filter United States, it will filter, some position which is marked as New York. So I don't know, but such filter is really stupid because it put city like Seattle and the country in the same category, in the same level. It's really ridiculous actually. Okay, this is agentic. This is finance. This is legal. This is data, design, research, inference, internship, developer, marketing, ML, modeling, people operations, platform, IT, security, product, revenue, customer success, but it's in UK. Solution architect is Tokyo, Dubai, Ottawa. Ottawa, where it is? I don't think it's in America.
Ottawa.
Ottawa. Oh, I think it's in Canada, huh? But if it can work remotely, maybe. Oh no, it's for public sector. Yeah, yeah. You need to, have the security clearance, so it doesn't work for me. Anthropic. Well, I have applied it recently as Anthropic. Also, Scale AI, I also apply for it. So in the list, well, anything else? Max of Amazon 100 face. Cohere. Yeah, I think it's. Let's try see whether 100 face has something interesting. It's very few position. Oh, that's really good. It detect my location and show the jobs. I think this details is very, very helpful. Research engineer, test engineer. Okay, all of it needs. Okay, there's no such customer sales account executive. Customer success. I don't know. Okay, this is account executive. That sounds like an interesting role. How about this one? Cloud machine learning engineer. Okay, I think this one account executive, although it's not an engineer role, but well, maybe I'd love to try it. Engine phase. Okay, let's go back. Okay, this is a application strategy, networking strategy, LinkedIn cold outreach, target people to contact, and comparison between China and America. Okay. Key insights. US leads in fundamental model and architecture innovation. China rapidly catch up in specific application and engineering implication. US venture capital more active. Embedding as a service market more mature. Chinese big tech large internal application skill, but lies open source. Many Chinese AI PhDs stay in America after graduation. But recent increase in returning to China for startups. Interesting. Okay, three strategy. Stay in America, return to China, entrepreneur. Timeline. Skill portfolio. Dual network. Project portability. 3-year plan. Foundation. Goal. Focus. Set project. Year 2, growth. Goal, focus, set project. Year 3, decision. Goal, focus, and option. 3 options. Technical skills. Deep understanding of embedding technologies, cloud platform, Python, proficiency, API design and integration. Important. Next to have. Soft skills, communication, empathy, problem solving, cultural awareness. Okay, some technical interview questions. That's good. I don't have time to read it today, but I think maybe I will need them when I get some interview invitation. Behavioral interview question. Okay, some essential papers. Yeah, I guess I will start reading, those papers from January 2026. And the tools and frameworks. Vector database. YouTube channel. Okay, here's something I think that I can check it out. Some Chinese model, some evaluation benchmarks, online resources. That's great. References is given here. Yeah, that's pretty much for today's AI open source project review. Thank you.